In number 4, we're going to do a second type of use substitution. The previous kind was an integrand that looks similar to a chain rule derivative, where we had the derivative of the inside on the outside. That's not the situation here. Here the inner function is 2x minus 1, and the derivative is 2. On the outside we have x. So we don't have that same situation where we have an inner function and we have the derivative of the inner on the outside. What we have here is an inner function that's a linear function. 2x minus 1 is linear. That means x appears to the exponent of 1. All right, so that's a linear function as an inner function. We're going to set u equal to our inner function and differentiate. All right, now to do our substitution, we have to substitute everything in this integral piece by piece. All right, so let's do that. Well, for dx, let's divide by 2 again. For dx, we have 1/2 du. All right, so we got rid of dx. Square root of 2x minus 1, we have square root of u. u is equal to 2x minus 1. But what about this x over here? Well, to substitute for x, we're just going to take our u substitution and solve for x. So let's do that. So we have, just solving this little expression for x, we have u plus 1 equal 2x. So we have x is equal to u plus 1 over 2. So we'll put that for x. And of course, let's simplify this. This 1/2 in the numerator we can bring in front and multiply by this 1/2. So we have 1/4 u plus 1 over square root of u du. Now let's see what we accomplished. Well, what we ended up with is a quotient where the denominator is one term. So we can divide by this denominator and obtain the sum of powers and integrate in that way. See, here the denominator was more complicated. We simplified the denominator. The denominator is a power, u to the 1/2. We can divide the numerator by u to the 1/2 and use the power rule. So basically that's what we did. We did this simplification. Okay, we simplified the inner function and we got a simple power. And that's what we always do when we do linear use substitutions. We simplify the inner function so that we get a simple power, something like square root of u or u to the 10th, something like that. All right, so now we're going to divide and rewrite this integral. U divided by u to the 1/2, that is u to the 1, divided by u to the 1/2 is u to the 1/2. 1 over u to the 1/2 is u to the minus 1/2. So now we have something we can integrate using the power rule. So let's start. U to the 1/2, add 1 to the exponent, and divide by 3/2, which is the same as multiplication by 2/3. U to the minus 1/2 plus 1 is u to the 1/2. Divide by 1/2 or multiply by 2. And now we'll substitute back u is equal to 2x minus 1. So we have 1/4 2x minus 1 to the 3/2 times 2/3 plus 2x minus 1 to the 1/2 times 2. In number 5, once again, we're going to do a linear substitution because look at this inner function. it's a linear function, x to the 1 plus 1, but we do have limits of integration here, so we're going to see what to do with those, all right, in a minute. But first let's write u equal to x plus 1, and in this case we have du is equal to dx. And let's solve for x. X is equal to u minus 1. All right, so let's start our substitution, and we get, for x, we're going to write u minus 1. For square root of x plus 1, we write square root u. And for dx, we have du. But what about these limits of integration? These are x limits. In other words, this is x equal 2, and this is x equal 1. So we have to change over to u limits of integration. All right, and we're going to do that using our change of variable expression. All right, so first let's say, let's rewrite this. Okay, so when x equal 2, what do we have? We have u equal to 2 plus 1. We have u equal to 3. And when x is equal to 1, substitute 1, we have u equal to 2. So those are our u limits of integration. All right, so now let's proceed to integrate. Now we changed this complicated expression, square root of x plus 1, into a simple power, u to the 1/2. Let's rewrite that as u to the 1/2. And that simplifies things because now we can multiply through and get a sum of powers and use the power rule. That's the pattern here. U times u to the 1/2 is u to the 3/2. And now multiply minus u to the 1/2. And now we're ready to do the power rule. Okay, so let's do that. So we have u to the 3/2 plus 1, that's 5/2, multiplied by 2/5, minus u to the 1/2 plus 2/2 is 3/2, divided by 3/2 or multiplied by 2/3. And now we'll just substitute in our limits of integration. Okay, substituting in 3, we have 3 to the 5/2 times 2/5 minus 3 to the 3/2 times 2/3 minus 2 to the 5/2 times 2/5 minus 2 to the 3/2 times 2/3. Okay, we can't really approximate this without a calculator, so I'm just going to leave it as is.